This is silicon, more pure than even nature makes it. Pure silicon doesn't carry electrical current well. But when you add certain kinds of impurities, such as boron or arsenic, very interesting things happen. And what happens is the phenomenon that led to the invention of the transistor by the laboratories in 1947. The transistor amplifies or boosts in strength an electrical signal. Here's how it does it. It accepts a weak incoming signal, then recreates the same signal, but increased in strength many, many times. There are several types of transistors. This one has three parts: an emitter, a base, and a collector. The incoming signal passes first into the emitter side, then into the base, which is a sort of valve that controls the strength of the signal when it passes into the collector side. Two sources of power are involved in this process: a small battery, through whose circuit the incoming signal is fed, and a large battery, which pushes the signal on its way. Let's look a little deeper. A transistor is made from a slice of pure silicon. To allow electrical current to flow through the silicon, tiny amounts of arsenic atoms are added to the emitter side and to the collector side. The atoms give these sides extra electrons, which are negative charges. A few atoms of boron are added to the base. Boron provides extra holes, which are positive charges. It is the interaction of these negative and positive charges that helps make the transistor work. But the negative electrons can move only when an electrical current is introduced into the transistor. Watch. The negative electrons in the emitter side are attracted into the base because the small battery makes the base more positive. Positive attracts negative. From here, the electrons flow into the collector side, driven by the large battery. Let's see what happens when only the large battery is working. The electrons are pulled away from the base by the voltage of the large battery, leaving only positive charged holes. Thus, no current flows. But when the smaller battery is connected, the negative electrons are injected from the emitter into the base, and from here respond to the power of the large battery. So the current which flows is controlled by the small battery and has the power of the large battery. Now let's connect a weak telephone signal to the emitter side. Variations in the telephone signal control the flow of electrons through the valve-like base into the collector side of the transistor. Now the signal current is pushed by the large battery, so it is much stronger than before, as much as 1,000 times stronger. In other words, the signal is amplified